All right, so I want to talk a little bit about this project that I made. First, I'll just demonstrate and then explain it. So it's a decompiler. Um, yeah, so this is the code. It's kind of messy. Um, Let me just run it real quick. I actually just realized I didn't even finish the output part, but okay, so it's down here, but to make it a little easier to see, I'll put it in a file here. All right, so this was my output. So the left-hand column is the machine instructions in hex that was fed into it from a file, and the right-hand column is it decompiling the machine code instructions into ARM assembly. Lot of problems. It's not a fully finished project, but you can kind of see here that it works. And yeah, now just to kind of start over and explain from the beginning, because I don't really have a target audience. I won't spend hardly any time on this, but basically, the normally what you would do, say you're writing code and you might produce some assembly instructions that look like this on the left hand side, and then after you write those instructions, an assembler will transform them into numbers, binary ones and zeros, which can be viewed as binary, octal, or hex without really hardly any conversion. Um, I mean, there's conversion, but it's not the same as when you go to decimal because I don't know how to say it, they're powers of each other or something along those lines. But anyway, so it turns it into binary, and I'm going to kind of binary and hex. Think of it that way too if you want. Because the reason I say that is because the tool that I'm using views it as hex, and you'd often view it as hex, but technically it's in binary. It converts it to binary. So um, yeah, so in a nutshell, that's what goes on. So a decompiler is a tool where you start with the numerical values and you transform those into um, something that looks like text. And so there's quite a lot of differences between the project that I've made and what could be like a full functioning tool. One of them is I don't actually know if it automatically breaks up the lines for you. I mean, I suppose it wouldn't be that hard because they're going to be the same length, but I didn't have to do that for mine because so what I did was I wrote this basically what that was already done for me, and I'll explain how. So I wrote this assembly code a while ago for another project. It's just a simple little thing that simulates like running an elevator, and it's just like for study purposes. It's nowhere near complete or like what you could actually use to safely run an elevator, but it's functional. So this is my assembly code, and I wrote it to use inside this amazing tool that somebody made. I don't know who made it. The website's right here, but this tool. And so if I just copy and paste my code here and then run it, except I have to delete the comments because for some reason this tool can't handle the comments. So we'll see if I missed any when I hit compile and load. Failed. Where is that at? Does it tell me where that is? This is somewhere I missed. There's one comment. Succeeded. Okay, so you can see on the left-hand side here, it produced these this machine code, and this tool shows quite a lot of things. But so just again, real basic idea. So how much this do I want to go into? You basically you have these registers that are memory that's part of the CPU, and then you also have memory that's in RAM. It's not part of the CPU. That's what's intended to be represented here, and the RAM memory here is holding my program because we just loaded it into RAM. And so the instructions follow along here. They kind of start in the middle. I'm sure there's a reason for that. Normally you'd have like your operating system and firmware and all kinds of other stuff running before you even get to anything that you would possibly write. But so so here's my first instruction: E3A, a bunch of zeros and a 4, E3A, a bunch of zeros and a 4, it would be E3A 01003, E3A 00 blah 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 3. And if you go down this column here on the left hand side, and if you go across these memory locations, I'll just call them that, these memory locations, you'll see the whole program. I forget where exactly it ends. Probably right here, because this all looks like junk. Actually, I think it's all the zeros was the exit code. Anyway, so that's real basic short. This is again, this is in hexadecimal, but this could be viewed in binary. It technically is in binary, but it's typically viewed in hexadecimal because it doesn't take up as much space. And so what I did was, to be honest, it's been a long time since I think I actually wrote all these out by hand. But I got, so I use this tool, this web tool, to convert my, looks better here, to convert my assembly code program that I wrote into some machine code that's viewed right here. And then I wrote down that machine code somewhere. It looks like I don't even have it open. Actually, I forget where it's at. Is it this one? This one. So this is my whole program in machine code. So it's line by line. So then the way that my decompiler works, and then you can point out maybe quickly some other problems, right? So one problem is I don't think it's given to you. I keep losing that. It's over here. Do side by side. I don't believe it's given to you line by line, so I would have to split it up because it's probably going to look more like this, where it's just a bunch of stuff pushed together. But that wouldn't be so hard because they're always the same size. They're always the same size, so that would be relatively easy to do. And then as I go through here, so just kind of, I don't know, the way this works, I guess. The first thing I do is I read in all the lines. Then I had it turning it into a 2D array where the left side was going to stay the machine code, and then I just copied the machine code again to the right side because then I'm going to change that later to the like the opcode, the assembly instructions, so that then they can easily be viewed side by side. Then I'm going to have to convert to binary because the way that the machine instructions work, they look about like this. Is this a nice one? So this is the code where I kind of by hand converted about half of it so that I could make sure I was understanding the instructions correctly. So this is that first instruction, which is here on the left. I just put some spaces in there as I was trying to analyze it. But this is that same first instruction that we looked at, E3A00004. This is it in binary right here. And I split each of the digits up into the groupings that are important. So the first number is a condition. The second number is an opcode, even though the opcode doesn't automatically mean an instruction. The couple of these things combined together equal like move versus store versus, so I have a load register. I don't see that right here, but so the next one, these are some kind of flags. I don't know what each one of these stands for, but they kept labeling them as I, P, U, B, W, L. I just put them all together because for my purposes, that was good enough for what I was doing here. Then you have, I don't know what RN stands for. It's going to be register something, but this can be usually a from, like from some register. And then this should probably stand for register destination, I think. Destined register, I don't know what exactly is, but that's what it means. So it probably stands for register destination. And then source is often the number if there's a decimal value that you would have in there, or hex value, just a number. That's usually going to go here in source 2. And so basically what my thing does here, yeah, so I split it into binary. Then I split it up into tokens so that each, I'm not sure if these are technically tokens. I think it's fair to call them tokens. That's what I called them. So each, now it's actually not just two deep. It's not like a 2D array. It would be a, let's see if I think it's like 8D. 1, 2, 3, 4, 5, 6, 7. Plus there's going to be one more for the original assembly code, uh, or the original machine code instruction. So without it, just in hex basically. So uh, 8 deep on the array there, and then now that I have it all split up like that, I use a bunch of switch case. That's what I'm at. Yeah, or case match, I guess what they call it in Python, to check these the necessary tokens to see what the token flags it as. And so if so going back to those registers, the condition for all the ones I had in my program was always the same. So I just ignore it. The opcode, there was a couple options. The opcode could be a 1 or a 2, which is 1, 0 in binary. And then IPUBWL was often significant. So that's this next case thing here. So if your opcode is 1 and IPUBWL, for the ones that I looked at in my program, that would tell me, whether it was going to be a move instruction, compare instruction, and then if the case was 2, but the whatever that is in decimal, the next one, the flags were this value, then it's going to be store register. If it was this value, it's going to be load register, and then this value is also load register, but with another another way of doing it, basically. So that kind of highlights another problem, right? So I didn't sit there and account for every possibility in the machine code, and I skirted over some of the things. Like, I'm sure it would probably be more necessary to understand what these flags, so like these flags right here, IPUBWL, to understand exactly what they do and to split out and pay attention to those flags. I'm also sure there's a much faster way to lay out the code than the way I laid it out. And yeah, mostly it does work though. So if you look at the instructions, these were the ones that we output, and you compare them to my original instructions here. And as I do that, it'll be easier to point out some other problems. So I start here. So this stuff is not in there. Comments are not going to be in there. Actually, I didn't start at the top of my program. This is the top up here. These I did not account for, and the way that I would want to do that is to, I won't be able to get the names obviously, but these names are storing like important places basically that have labels. And so I would want to point back to these labels, and eventually you want some way to kind of analyze that that was an important label. Maybe you could give it a name. It'd have to be really generic though. I mean, you couldn't call it encoder obviously if you're just decompiling because you don't know what it is, but maybe like label A or something other than just a number. So there's something that's missing. As I go down here, so there we go. For some reason, this first one here comes back as move, and I wrote it as load register. All of the rest of them work just fine. And I looked through the documents, and I don't actually know if that's just some weird thing with the assembler or a bug with the website, or I'm not sure what exactly is going on there, but I could not see why this was coming back as move instead of load register. But I mean, they're really close anyway. There's not a lot of difference between the two, so I don't see that as too big of an issue. I have some issues. I don't know. Let's see what else was. The compare, and so I didn't say that. A bunch of these I just skipped. In order for time's sake, I didn't have time to finish going over all the instructions that I used in my program. So if it's not there, comes up saying that it's skipped. And that's kind of a feature and kind of a just means it's incomplete. But I think that if you were to develop something like this to really use on a project, that would be a good thing to have because you may be missing something or there may be something you can't identify. Maybe I could have it say, come back, like say, this was not identifiable or something like that. So you'll see quite a few of those in there because the project was getting too long. Another thing that was really interesting that I could not figure out quickly enough and I didn't want to get stuck on it for too long, my compare instructions worked and correctly produced the desired effect, except when the number got too large. When the number gets too large, there's something unusual going on with the flags. So like this one right here, actually see, that's not correct. If I go to the code, this section right here that has these compares 1, 2, 4, 8, 16, 32, 64, 128, this should be 256. I kept them in order like that. But for some reason, there's something odd going on there with the flags. I spent a little bit trying to figure it out, and then I didn't want to get bogged down on it, so I just left it, but that is a bug. Can't seem to find it now. It's this right here. So yeah, I go 1, 2, 4, 8. Wait, maybe I don't go how I thought. Anyway, you can see it's not as big of a number. I think that's the only place that occurs. It is. So it's not a number in the thousands. For some reason, once these numbers get bigger, there's something odd that flips over in the flags, and it was not listed in the documentation that I was looking at, so I'm not exactly sure what's going on, but that's why I get bogus numbers after. So we have 1, 2, 4, 8. I don't think this should be 16 actually either. 1, 2, 4, 8. No, sorry, that's 16 because this is hexadecimal. 16, 32, 64, right? Yeah, I think I kept going with that. 128, and then I believe this should be 256, if I remember right. And that's where it breaks because there was some weird thing going on with the flags that I just didn't account for it. So that would be something that would need worked on. What else? I think there was another place where something weird was going on with the flags that I just decided to leave it incorrect, but I know that it's not correct, and it was down here. We have, I think it was these load. One of these had two. Was it compare? I think I actually need to look here. I think it was store. In store, I made this to kind of the dots. The asterisks tell me that sometimes changes, but I actually did not see what the other one was doing here, so I just left it. So this is only actually accounting for some of the options that I have in my program, and then for others, like another problem that I know exists, like for move, for example, this does cover everything that occurred in my program, but if you look up the documentation, move can occur other ways than what I used, and so it's not going to be in my decompiler because I literally just wrote this to decompile what I already wrote, instead of trying to make a full decompiler that could decompile all, the ARM assembly instruction set. That would just be too daunting of a task. But yep. So yeah, that's yep, this is the output, and you'll see the machine code and the ARM assembly. It's definitely a big start.